This video is the second video in a series of 4 videos through which we'll learn how to use the table for the standard normal random variable. Here specifically we will learn how to find probability of z bigger than k for positive case. The method we are learning is going to work for all cases, but specifically we will work for positive ones because we only know how to read the positive values from the table. So let's start recalling that the table for the z, the table only has values probability of z less than k for positive case. So that's what we know so far. Okay, but now if someone wants to find probability of z bigger than a positive number, we start with the point that probability of z bigger than k is, well, you remember that this PDF of z has this bell shape, and bigger than k, if k is here, then bigger than k means the region, the area of this region. Well, with very simple observation, this is, you can call it the complement observation. What we can do is that we can find this area of this red shaded region by doing this operation. So if we first find the area of the whole region, the total region, and then subtract from that the complement of this piece, the complement of that will be everything like that. Yes, then it's done. But the good thing about this part is that, while this piece, this is the area under the graph of the PDF, which is always 1, minus this part is probability of z less than k, and this is a number from the table. So to find values like probability of z bigger than k, what we do is we use this equality. Probability of z bigger than k is equal to 1 minus z less than k, and then this value here is something that we can find from the table. Okay, so let's do some examples here. Example, find the given probabilities. And here I have 3 examples. Probability of z bigger than 2, probability of z bigger than equal 1.57, and the third one is a probability of z bigger than 3.45. Okay, I need the table. Let me import the table here. Okay, just this page, and that's it. That's there. Okay, let me just shift it a little bit up there. That's the formula we need to know to turn z bigger than equal to k to z less than equal to k. and then from the table we can find it. Okay, let's just go ahead and do this. Z is bigger than 2. I can write it as probability of Z less than 2. And then I can find probability of Z less than 2 from the table. Remember that 2 is the same as 2.00. So I need to find 2, 0. This is 2, 0. And then 0.00. This is this guy. So the intersection of these two, that gives us the value we are looking for. It is 1 minus 0.9772, which when you subtract you get 0.00228. That's the probability we were looking for. This other one, one thing that you have to remember here is that Z is continuous random variable, so it doesn't matter if the Z bigger than equal or just bigger than. So those are the same things for the continuous random variables, and return bigger than equal, Z is bigger than equal to probability of Z less than by applying this formula, 1 minus probability of 1.57. And this is 1 minus, this is 1.5, so let me find 1.5, and 0.7, so this is 0.7 here. So we go this way, we go that way, the intersection is 0.9418, and that gives me 0.058 and 2. Yes. And the last one is, again, this is bigger than positive, so you go 1 minus probability of Z less than 3.45, and then 3.5, I need to find it from here, 3.4, and then 0.5 is there, so we go down here and then right here, and that's the number. 1 minus 0.9997, and that gives us 0.0003. That's the probability we were looking for. Well, you remember that sometimes we have examples that probability is given. Now we are trying to find Z. So let's do two examples for those ones. Example, find the value of K for which we have, first one is probability of Z bigger than K is equal to 0.2358, and then the second one is find K such that probability of Z bigger than K is equal to 0.0571. Very nice. Okay, so remember one thing is very important. Knowing one thing is very important. This table is for Z less than K. So if you see Z bigger than K, first turn it to Z less than K by doing the complement thing. So it will be Z less than K is equal to 0.2358. And then just bring probability of Z less than K one side, and then it will be 1 minus 0.2358. And this number is what? 2, then we get 4, then we get 6, and then we get 7. So now we are looking for K, which probability of Z less than K is 0.7642. 76 should be somewhere up there. Yes, 7642. This is the value. So this is the probability. How do you find k? So you pick first digit and the first decimal from the first column, that's 0.7, and then the second decimal from the row. So this is 0.72. How about probability of z bigger than k equal to 0.0571? Well, this is bigger than. I have to turn it to less than by turning the other way around, and that gives us 0.0571. And then you do solve it for z less than k, and that gives you 1 minus 0.0571. Oh, well, this is 9, then this is 2, this is 4, and then this is 9. So 0.9229. Find z, that probability of z less than k is 9229. 9429. 94 is here, then 20, oops, 94, I can, oh, 9429, it's here, sorry about that. And then you just, well, find the oops, x part, this part, then that means that k is 1.5 and the second decimal is 8. Okay, so just quick review of what we did was that if probability of looking for probability of z bigger than k, use this formula, turn it to z less than k, and then you can find it from the table.